Example 4. Here's we're looking at continuing and finding inverse functions. Let's talk about this quadratic function. Now let's go ahead and talk about the domain of f of x. Well, domain of a quadratic degree two polynomial function, right, is all real numbers. Right now, if we graph a parabola, it's a U-shaped graph, which is not one-to-one. It would fail the horizontal line test. So you'll notice they've restricted our domain. So in our domain of our f function, we're looking at all real numbers greater than or equal to 0. So we can go ahead and state that. There it is in interval notation, x greater than or equal to 0, domain being all the real number values of x. Of course, we also know the range of f inverse function, since we know the domain of f. We know all the y values, so remember range is y will be from 0 to infinity. As we graph in this inverse function in a little bit when we find it. So again, when we even begin, we know that. Now let's go ahead and get a quick sketch of the graph of the quadratic. Now you remember y equals x squared graph, right? As we're graphing it in, we can go ahead and graph in a quick sketch, right? And I'm going to dash it in here of this parabola, this U-shaped graph here. Now as we look at that, of course right now it passes through 0, 0, passes through 1, 1, it passes through negative 1, 1. See y equals x squared graph. Now we want to graph x squared plus 3. So to graph that, now I'll graph it here in black. We know the plus 3, right? That shifts our graph up 3 units. So as we go up 3 units, the vertex 0, 0 moves up here to 0, 3, right? We know 1, 1. If we go up 3 units, it would move up here to 1, 4, right? And again, same thing goes for negative 1, 1. It'd move up negative 1, 4. So graphically, right, we're graphing in our new quadratic function, right? This is the shape of that graph. Now, with that said, that's not a one-to-one function, right? That fails the horizontal line test. So we were to draw a horizontal line, it crosses more than one point. So there's, again, more than one x for the same y value. Each y must have exactly one x to be one-to-one. So, again, we have to restrict the domain. So let's go ahead and do that. Let's go restrict the domain to what it said, x greater than or equal to 0. So, again, we'll wipe off this side of the graph. So there's our graph of our function here we're looking at. And we'll go ahead and write that here beside it. So here's f of x. Right, equal to x squared plus 3, right, with a domain of all values of x greater than or equal to 0. And again, we want to plot a couple points, 0, 3, and we know 1, 4, a couple points on this graph of this f function. So again, just using transformations, right, as you see, again, a quick graph of it. Now, let's go ahead and look at the inverse function. And while we're at it, I'm going to go ahead and erase off x squared graph. Clear that graph off a little bit. As we look at the inverse function, let's go find it. So finding f inverse of x. So let's go ahead and look at our two relating variables, f of x, which is y. Y is equal to x squared plus 3 for all x greater than or equal to 0, which now means we're going to be looking at all y values greater than or equal to 0. So we interchange x and y. Right, we've already stated our range on the inverse function. Now, step 2, right, let's swap out. Let's interchange x and y. So where we see y, we're going to put x. Wherever we see y, we're going to put xx, we're going to put y. So x equal to y squared plus 3, right, in the inverse relation. So again, we're interchanging x and y. All right. With that said, let's solve it. So now we're ready to find our inverse function. So what's our third step? Let's go ahead and solve for y. Now that we've interchanged x and y, we found the inverse relationship. We got to create the inverse function. And to do that, we got a couple steps. Let's go ahead and subtract 3. Move it over. And as we do that, we get x minus 3 equal to y squared. Now we need to take the square root of both sides. Since we got y squared, we want y. Take in the square root. And as we do that, we get y equal to the square root of x minus 3. And it can be plus or minus. Now remember, we're restricting our range y to be greater than or equal to 0, so we want the positive, right, output for the square root function, not the negative. So again, we need a square root x minus 3 graph. Now, square root graph, if you remember, square root graph, and we can graph it over here. So let's sketch in. So we found this inverse function, f inverse of x equal to the square root x minus 3. Let's go put in here this graph. All right, now put it in here in a different color. So square root x graph begins at 0, 0. When the graph it passes through 1, 1. Square root of 1 is 1. Right, we want to sketch it. Right here is where our graph would be. And then as I take the square root x graph, right, if we want to graph square root x minus 3, right, we know we're going to shift it to the right 3 units. All right, so again, 0, 0 would move over here to what? 3, 0. Right, and of course 1, 1 would move over here to 4, 1. And we can graph it in. Here's our square root function. Again, we've got our graph now of our inverse function. So f inverse of x equal to the square root of x minus 3. And we can erase, right, our other graph here, our transformation. And you can see it. Now, we have talked about that these are symmetry. We haven't mentioned that, but let's go ahead and look at the symmetry line. Remember, you can always check your inverse functions. Remember your symmetry line, I'll put it down here. We know the symmetry line is a line y equal x. So let's take a look at the graph of the line y equal x, right, as we've graphed in the inverse functions. So line y equal x, of course, a line with a y-intercept at the origin and a slope of 1, up 1, right 1, right? We graph in y equal x. Here's y equal x on our graph. And you can see the symmetry that we have with these two. So you can see f inverse x and f of x, right, are symmetrical to that line, right? They're reflections about that line. So again, you can see the symmetry. So remember, that's our test line, right, for all inverse functions. Now back to our question. We haven't answered the domain of our inverse function. So we found the inverse function. Let's go ahead and put in the domain. Now, domain is where this graph takes place on the x-axis. We graphed it already. Domain is what? 3 to infinity. All x values greater than 3 to infinity. Right, which we can see. If you remember with these even roots, we can find domain by hand. Right, we can't take the even root of a negative. So when is x minus 3 greater than or equal to 0? When x is greater than or equal to 3. Right, so you can see that too as we solve it for x. So with that said, that's our domain. Now, range of the f function, which we saw the graph earlier, we can see the range of the f function is from what? 3 to infinity, right? We graphed it earlier. Where does it take place on the y-axis? Well, remember, it always equals the domain of the inverse function. So as we look at the range of f of x, it has the same thing as the domain of f inverse of x. But again, these are a list of all the y values, 3 to infinity. So you can see, again, that relationship. Domain of f of x is equal to the range of f inverse of x. And vice versa, the domain of f inverse of x is equal to range of f of x, right? We're swapping out x and y. X and y is our domain, our range.